Everyone, welcome. Good morning, good afternoon, good evening, wherever you are in the world. Welcome into today's webinar. We're just going to give it a minute as we wait for folks to trickle in to the room. We do have a large attendee list here today, so looking forward to that and just giving everyone a minute to get settled into the room here before we get started. So just hang out for about 1 minute. And again, for those just joining here into the room now, we are just waiting for about 1 minute as we wait for everyone to trickle in. Always takes a little bit for everyone to get joined in and get started here very shortly. Okay, looks like we have a good quorum of folks here attending in the session today. So we're going to go ahead and get started. Today's session, Nautobot Navigators Webinar Series Part 2, Leveraging Nautobot's IPAM Data Model. So today we'll go through our intros as always, and then we're going to dive into the topics for today's discussion, exploring IPAM and going through the various sections within Nautobot, specifically the prefixes, the IP addresses, VLANs, as we look at using IPAM within Nautobot and how you might model your IP infrastructure. Look at some tutorials, possible things you might go try out using the Nautobot sandbox, and example use cases, and of course, Q&A as always at the end. So for those of you that have seen other of these series, you know me, but my name is Tim Shryack. I'm the Director of Sales Engineering here at Network to Code, and happy to take you through this session today as we learn more about Nautobot's IPAM functionality and using it. And of course, we have a complimentary 2-hour hands-on Nautobot workshop on May 30th. This is a free session exclusively for y'all here on this webinar today. It's going to be on May 30th, as I mentioned, and it's going to focus on Nautobot's various use cases, including its role as a flexible single source of truth for network operations and extensible data and app platform. It's got hands-on labs. It's a really great course. You get to experience all the things within Nautobot in a brief 2-hour session. It does have extremely limited availability. I want to emphasize that, particularly on this one. We've had a lot of interest in our other courses we've done like this, and there's very, very limited availability. So if you're interested, please sign up as quickly as you can using that link that we just dropped there in the chat for you. This is also a good time to get a taste of what our full courses look like, so you can begin to experience what a Network to Code learning session is like. They're really great, really well led by our instructors, including those hands-on labs. So just a quick review of what we went over in the previous webinar on our part 1 of the Nautobot Navigators webinar. We looked at the current network management challenges, current and possible states of network management, gave an introduction to source of truth, which is expressing our intent versus reality, did a Nautobot overview, and then dove deep into a few topics. It's available out on YouTube. It's about 50 minutes long if you want to have a chance to take a look at that if you haven't already seen that. It's a great overview into beginning with Nautobot and why you might want to use it in your environment. So definitely check that out if you have some time after today's webinar, if you haven't already seen it. Okay, so now let's take an example or a story around why I might be interested in using Nautobot's IPAM functionality if you aren't already using it today. So where does it fit in your environment? Kind of where are you at now? So we often see folks in sort of 3 major categories today with their IPAM infrastructure, which is you're using something like a spreadsheet to model your IPAM. You're using a tool, maybe like PHP IPAM, some open source tool. And then you have the more paid for products, things like Infoblox, right? So you have those sort of 3 major areas where you might be modeling your IPAM infrastructure. Now, what is the advantage for each of those as we kind of look across that? So first, spreadsheets. moving into a tool that's actually designed for and can model your IPAM infrastructure is far superior to something like a spreadsheet. First, we have the capability to model our content. So we gain that IPAM tool functionality, and then we're also able to leverage the automation platform that Nautobot provides. And you can kind of see a similar story when you look at something like PHP IPAM, which is while we are taking that base functionality you already have in a tool like PHP IPAM or similar, not just that might, just a good example, we are enriching that through the use of the source of truth that's available to you in Nautobot, as well as the automation platform. And in both of those cases, what we would recommend is that you are going to transition from using those tools to using Nautobot, because we believe the Nautobot solution is superior and will give you a better experience and a better way to model your data. Over on the Infoblox side, now this is an example where we see often integration with Nautobot and Infoblox. Infoblox provides DDI functionality, that is DHCP, DNS, and IPAM. Nautobot does not provide those first two functionalities, that's DHCP and DNS. So in that case, what we often see clients doing is integrating Infoblox with Nautobot. And the reason they're doing that is getting a harmonious view of the data in their environment. So we want to ingest that data from Infoblox into Nautobot, as well as we're able to then take advantage of the automation platform that Nautobot provides. So those are two compelling stories around why you might move from using your spreadsheets or PHP IPAM into Nautobot. And then the other side is, hey, I've already got a great tool like Infoblox, but I want to be able to enrich that data and use it more successfully in my environment. Quick note here as well. We did disable the chat. You may have noticed that in the webinar today. So please do use the Q&A if you have any questions or want to interact with us. We will see those coming in for us, and we'll be able to get those answers out to you. So please use the Q&A as we go throughout the session today with any questions. So now let's dive into IPAM and modeling prefixes within a Nautobot. And during the webinar, we are going to assume that you as a listener are familiar with IP address management concepts already from a network engineering perspective. So we aren't going to dive into those and why you might choose to use one hierarchy model versus another. We're just going to show how you can achieve those concepts within Nautobot. So starting off with our prefixes overview. The highest level prefix we have is the root prefix. This does not require a parent. A parent prefix would be a second level of the hierarchy, and it must be of a type of container. So that's not an option there. As we look at our parent prefix, it must be of type container. And we will go through these concepts here in a minute as we explain what each of these types do and how we might use them. But here's just a quick overview. Then we have our parent-child prefixes. These are below that second level of hierarchy, and their parent has to be a container, but they themselves are containers or networks, right? So as you move down the tree, you now start to expand out what your type possibilities are. And some prefixes may exist as both parent and child prefixes, depending on how they're used in your environment. IP addresses then can be ecstatically assigned from here, so long as the type is a network. Right? So this is a key thing to remember when we're assigning out IP addresses within a prefix. That particular prefix must be of type network. Type network, also just to highlight, makes the first and the last IP unavailable, as those are your network and your broadcast addresses. So essentially what you're looking at here is taking the idea of prefixes and the way that we do subnetting and or supernetting and implementing those rules into the data model. So that's why at first you might think, I got to do all of this type container and a type of network. And really all you're doing is expressing what you already know about how you do IP prefixes, and you're expressing those into the data model. Right? So it's just kind of making sure aligning those concepts in your head between what you already know and how it's implemented here on the data side. Then we have pool prefixes. So these would exist at the very bottom of the hierarchy, and their parent must be of type network, and they're used to dynamically assign IP addresses out. So this is where you would create your DHCP pool, for example, and your DHCP server would then utilize that pool. Every IP in the pool is available for assignment. So different from if you think of a network, right, where first and last are not available. Then finally, we have devices, right? Statically assigned IPs from type network. And the IP object itself has to be created before a relationship can be made to the interface on the device. I will hit this as well when we go into details on devices and assigning IP addresses, but it's a key thing to remember. We've got to have that IP object already in existence over on the IPAM side before we can use it on an interface device. Great. Okay, now let's move on here to our IP prefixes page. Just take a quick look at what it looks like within Nautobot as we view the menu structure. We will see, it is here over on the left-hand side of our menu, and we have these options available to us. And always remember, sometimes depending on the way you may have set Nautobot and or your installation, you may not see all of these columns. This can be modified under your configure and or filter, depending on what you have done. So make sure you may not see all of the columns in your instance, and remember to go up there and adjust that if needed. So first we have the prefix column. Here we see the prefixes, right? Very, very basic. Our namespace that this particular prefix is assigned to. What type it is. And this is really important. Remember to pay attention to this because this will determine what you can do with this particular prefix within Nautobot. Setting a status field, is it active? Is it planned for? Is it something that maybe doesn't have a status in your environment? As you can see here is an example of just null, right? How many children it has? Its utilization, whether or not you are using multi-tenancy in your environment. So if you have tenants or the concept of that, it may be something like business units. Locations, VLAN, role, and description. So all of these fields available for you here to describe our prefixes, and most of those are optional. A few are required. We're going to look at that next. So thinking about our prefix object. So first we have the prefix name, right? Up here, we can see the prefix itself here, which is 1000/16. The address must be expressed inside our notation, as you see here used. And the namespace, each prefix has to belong to one. This is a key thing to remember. Namespaces are required. This is how we are able to distinguish one group of prefixes from another, is by what namespace they are assigned to. Location field, on the other hand, though, is optional. So you do not have to use the location field if you don't want, but it can be used there to indicate, where we are assigning these IPs, or if we are assigning these particular groups of IPs to a geographic region. You may wish to use the location field, but not required. Our VRFs can be assigned to a specific VRF instance if necessary, but if none is, then it's going to just default into the global VRF, right? So there will always be a VRF assigned, similar to what you would see in your router or your switch. But if you do not actually need to select one, because it will default to global if you don't actually pick one. The type. So again, as I overviewed on the earlier screen, this adjusts how the prefix and its utilization as well is calculated. So for pools, every IP address is available, and its valid parent type is a network. For networks, first and last IP addresses are unusable, remember, our network and our broadcast IPs, and valid parent types are containers. And then containers serve as parents for pools and networks, and valid parent types for containers are containers. So kind of thinking that as you work your way up your structure there, right, we have our pools, we have our networks or containers, then we have containers, and finally our root prefix, which is also a container, right? So just keeping in mind that structure, and that will help you as you start to navigate how you want to model and build out your IP prefixes within Nautobot. As we highlighted on the earlier screens, we have the status field defining as prefixes operational state, a role, prefixes function, right? And this, you may or may not use again in your environment. You use as makes sense for you. And finally, utilization. So this is calculated as the total address space of a child pool types, plus the total number of child IP addresses. Now, this is actually a key point, and I will go further into this a little bit. Sometimes when we look at utilization, it can be a little confusing at first, but we'll explain here in a minute. So creating our container prefix. So let's start off at the top of the tree. We're going to kind of work our way down. We have our root prefix, and then we have our container prefix. So we're going to first create a container. And here we're going to say, 10.128.0.0/16. It's going to be in the global namespace. It's going to be of type container, and its status in this case, we're just saying reserved. Those are the key things that we need to put in. As you can see, also the bolded fields indicate required fields for you, so you know which ones you need to do as required. This allows us to begin creating the structure within Nautobot as we lay out our hierarchy and the way that you are using IP address schema in your environment. So next, we would move potentially to a network. So we have our root, we created a first container, and now we're going to build a network under that container. Again, specifying the prefix. It is going to have the namespace as well as global. Type will now be network, and its status here, again, we're just saying reserved. And again, just commenting, highlighting here, right, because we are subnetting, you will notice that the prefix length has changed, right? So now we've gone from a /16 to a /24. And of course, that means you could build out multiple child networks here of other sizes, right? /24s or what have you as needed in your environment. Now, finally, the third level down, as we look at the pool. So within that network, now we said, hey, we want to create a pool. We're going to use it perhaps for a DHCP or whatever. Maybe there be some other example in your case. But here, we're going with a /25. So we're taking half that /24, and we're going to use that as our pool underneath the larger network. Something to note as you think about the way IPAM is modeled or the data is modeled within Nautobot is the relationship between the parent and child prefixes. This is how we are distinguishing our utilization. So for the prefix, the /24, utilization is now 50% because we assigned out this /25 pool underneath it. But within the pool, utilization is 0. And this is because we have a type pool versus a type network, and the pool is a child of the network. So within the network, we only have 50% available to us to use, whereas down on the pool itself, it's completely available for us, right? So keeping in mind as you look at your utilization, this is something to remember that you may look at your higher level network and think, I have no host level IP addresses available to me. That's not correct, right? The host levels would be determined at the pool, not at the network in this case, because you have this child under here. So just remember that when you're looking at utilization and make sure you're looking at the correct thing as you examine that. So here, a little more detail, as I was just explaining, on the utilization percentages, depends on the type. So in the previous case, we were looking at a network and a pool, but now think one level up as you look at your containers. Containers are the way utilization is calculated there. It's the sum of the address space of all the child prefixes. Whereas on a network, it's the sum of all the child pools plus all the child IPs, right? Because on a network, you could potentially have a pool, and then you could also have child IPs assigned out under that network as well. So in that case, you would have both the total pool space available and any child IPs assigned out would become part of that utilization calculation. And then finally, of course, the pool, that's pretty straightforward. That's just the total number of IP addresses within the pool's range. So hopefully that helps explain the way utilization works, because when you first look at it, if you're not familiar with this concept, that might be a little bit confusing. Please do feel free to ask us, further questions if that's not clear. Okay, so now let's dive into IP addresses, right? So now we've taken a look at prefixes and how we use those. Now let's start to look at our host level IP addresses, essentially our /32s. Although, of course, we all know a /32 could potentially be a network, right? So first, just a quick glance at our IP address page that is separate from your prefixes. So now we're into the IP address section within the menu structure over here on the left. And similar layout of our columns, other than we have things like now the IP address instead of the prefix. And we can see if the IP address has been assigned or not, which is a really interesting use case, as well as the DNS name can be potentially incorporated here into Nautobot. So some additional functionality due to the fact that we do have now host level functionality within Nautobot as opposed to our prefix level. So we can see how those are used. So let's look at the detail of a specific host here in this case, /32 10.0.0.0.0 as our host level IP. So the namespace, we highlighted this on prefixes, but let's just go over it again. It designates the boundary of uniqueness for our IP address space. Duplication is not permitted within the same namespace. So this is how you handle duplicate IPs, is by using namespaces. This allows me to say, hey, in this particular namespace, this set of IPs is not the same as this exact same appearing IPs over here, right? Because I have duplication in my environment for whatever reason. Sometimes we do that because we have active data center and a standby data center. Sometimes that happens because we acquired a new company and they had overlapping IP space. There's lots of reasons why this happens, right? But we use namespaces to be able to distinguish that and make sure we can handle that duplication. Now, if you don't have those complications in your environment, first of all, congratulations, lucky you. But in that case, you may not need to use namespaces. You just use a single namespace to model your entire environment. But you can, as I mentioned, use them for things like mergers, acquisitions, maybe managed service provider. Maybe you're running networks for other people. And then you're for sure going to have overlapping IP space in that case, right? Now, an IP address can be used in multiple locations. So that's an example of where you might have a location such as a VRF and then a virtual IP, right? And in that case, we can use it in multiple cases, in multiple instances, sorry. The type. Again, here an optional field for you as far as it's used to indicate special functions of an IP, things like host, DHCP, VIP, maybe perhaps. You could use this in any number of ways that might make sense for you. And then status of the IP itself, we can have things like active, reserved, deprecated, custom. Examples of ways that you might use the status field in your environment as you move through usage of IPs in your world. Right? And then roles. So here we're indicating attributes of an IP address, loopback, redundancy, high availability, or examples of ways that you might use a role to indicate this IP serves this particular function or has this special attribute to me, and I want to highlight that. I want to be aware of that fact. You know, it's not just a regular host level IP address, if you will. And just a reminder, as we're going through here, if you do have questions, please do feel free to fire them into the Q&A. We have been getting a few in, and I will bring them up here at the end for overall discussion. But again, don't be afraid to ask questions. So we're going to take a look at ways in which we can add IP addresses into Nautobot. So first, we're going to start with manually creating IP address objects. There are two ways in which you can do that. We're highlighting here on the screen. One, over here on the left-hand side of the menu, next to the IP address in your menu, you can hit the plus button. Or when you're in the IP address screen, you can also hit the add button up here at the top. So you do have two options there for you, depending on where you are in the UI. Might make sense, one or the other. Again, Nautobot does require the use of the CIDR notation when you're entering IP addresses, so just always keep that in mind. And the IP addresses do require a parent prefix to exist before they get created. So as you're thinking about how you start to laying this out, if you're doing this by hand, going through the UI and using the manual option, you are going to want to make sure you go create your parent prefix structure first before you start going out and laying out your IP addresses, because otherwise you're going to get really frustrated. You're going to come in and try to create your host level IP, and you're not going to be able to because you won't be able to assign it to the appropriate parent. So make sure you do that first. One thing to also keep in mind, right? IP addresses inherit the namespace and the VRF from their parent. So an IP, and if you think about this in the real world from a practical, this is how it works, you can't have an IP that lives in a different VRF than the network it belongs to. So here we're just implementing that logic that you have in the real world here into the data. And then the namespace That's really important because that's how we're making sure that this IP is not overlapping with another, right? So it must inherit both the namespace and the VRF from its parent. You cannot change those at the host level. And again, if you think that through, that absolutely makes sense because you can't do that in your actual network either. Okay, but doing one-offs in the UI is great. But usually, especially when we're building out a new environment or laying out some new structure, or maybe using Nautobot for the first time, migrating from our spreadsheets into Nautobot, we want to do things in bulk. We probably don't want to go do them one at a time. And we absolutely can do that utilizing the bulk import functionality where we can import via CSV. Now, you can either copy paste that CSV text into the UI, as you see here in the example, or you can upload the CSV as well. So you have two options for you there as how you might do that. To begin this process, you're going to use this import button up here at the top of the screen when we're in our IP address session. The simplest way to get started with this is put in a few prefixes or one and put in some child IPs and do an export of that. That gives you your base CSV to start from. So that's the simplest way to get going. Then you go populate that CSV and then import it back. Right? That's the quickest way to get your accurate template so you understand what the CSV should look like, how it's representing the things you see in the UI versus the columns you see in the CSV. Two required fields that you must put in the CSV is your IP address and your status. Those are absolutely required, but we highly recommend you also include the namespace. Even if you are just using the global namespace, it's good practice to make sure you're always specifically calling that out rather than relying on the default. So we highly recommend that you do address, status, and namespace as you start to build out your CSVs and import data into Nautobot. Of course, all the other fields, optional fields, are available to you to use as needed, but these are the ones that you must get started with as you begin to import IP addresses into Nautobot. Okay, we're going to move on to VLANs and how we model out our VLAN infrastructure within Nautobot's IPAM. So here, we'll just take a look at the columns. Again, as you'll notice over here on the left-hand side of the screen, we're now under the VLAN menu section within the Nautobot menu structure. And above that is just below all of our IP addresses and prefix concepts that we have on the menu structure there. Right? So just look down a little bit lower and we'll find VLANs. So of course, we can obviously model the VLAN ID, most important part of the VLAN, but then we have some other functionality that we represent here. So potentially the VLAN could belong to a VLAN group. It obviously is probably going to have a name if we're having good practice. It may have a prefix assigned to it, right, depending on the type of VLAN that it is, whether or not it's used in various locations, and the multi-tenant concept, and then of course the other fields we all know already, status, role, and description. Those are used as you wish. So if we drill into the detail of an existing VLAN that we have here in the example, we can take a look at some things that that are required, right? Of course, the VLAN ID itself is absolutely required. And it is going to limit you to the 802.1q standards, which is IDs 1 through 4094. We can assign out the name, a very important state within most switches and routers, that we have to have a VLAN ID and a name. And then, of course, the status, which can be active, reserved, deprecated, etc. And then optionally, we can use our locations, tenants, and VLANs groups within the Nautobot infrastructure. So we wanted to create one. We're going to come into the create menu. Again, remembering the bold fields let you know this is a required field. We're going to put in the VLAN ID, its name here. So here we're creating a VLAN that we're going to use for our point of sale devices. And we're going to just set it up for the future, right? We're setting it up as reserved. We're going to plan as we're maybe building out a new retail location, perhaps, and we want to configure the VLAN for that new location. So now let's look at the groups. I kind of just glossed over this as we were first looking at the earlier screens. Let's take a look at how we might use them and what they do. So VLAN groups. First, we have a name that we can give to this group. its location, where it exists, the number of VLANs that are assigned to the group, and its description, brief description there, right? So groups are used to enforce uniqueness within VLANs. So a group to a location, but not to multiple locations. Right? So it can only be assigned to a single location. And VLANs in that within the group must have a unique ID and name. So this is similar to the idea of a namespace over on the IP address side, where we use namespaces in order to enforce IP address uniqueness. Now we're using VLAN groups to enforce VLAN uniqueness. This allows me to have overlapping VLANs concepts within my environment while modeling them into the data. VLANs, but something a little bit different. VLANs do not have to be associated to a group, and VLANs are by default not assigned to a group. So if you don't have a group associated to a VLAN, it does not have these restrictions within the Nautobot data model. So key element there, if you decide you want to use groups, be aware of the rules. If you're not using groups, they don't apply, right? So a little bit different than namespaces as we looked over on the IP address side. And just a little deep dive here into the group object. As we look at the details of it, we can see the relationships between the VLANs that are assigned there, how many are available to us, and what's been actually assigned out in that environment. And then here, of course, we can see that location. We're saying, hey, this is our Amsterdam site, and this is the VLAN group and all of the VLANs assigned to that particular location here in our point of sale group that we have for Amsterdam in this case. So it's just a way to think about adding and modeling your VLAN environment or your VLAN infrastructure into the data model. As far as creating one, pretty straightforward, right? We're going to assign the location, we're going to give it a name, perhaps a description, and that's the creation of your VLAN group. Again, always remembering if you're going to do this, you're going to want to create your group first, and then you can start to go add in those VLANs into the group. You will need to do that as your first step, as you think of that parent-child hierarchy within Nautobot. Okay, so that's the nuances and the details of actually using and adding IP addresses, prefixes, and VLANs in Nautobot. Now let's move on to some tutorials, some things you maybe could go do, suggest you would experiment with in either your instance of Nautobot or using the public sandbox. Just first, remembering the general order of operations that you want to take into account when you are creating and using Nautobot IPAM. Generate your prefix objects starting with the parents first if they don't already exist. This is absolutely required step, and you're going to get frustrated if you go to those lower levels first, right? Because you're going to be, I need to go create the prefix. So do that first. Then you're going to create your IP address objects. Next, you're able to then assign the management IP addresses to devices. So if we're thinking of the larger picture, the reason we're putting things in IPAM is because we want to actually use them. We're now saying, hey, I want to go add those IPs to my devices. So again, remembering that order, create your prefixes, create your IPs, now go to your devices and start assigning those IPs out to your devices. A little extra bonus step, it is possible to use the device onboarding application to populate additional information with very little effort compared to, say, doing these things by hand. So as we get this initial data into Nautobot, now we can use the device onboarding app to go discover additional IP addresses, additional VLANs, and automatically create those within Nautobot once we have that hierarchy created and the management IPs added to our devices, right? A key step, device onboarding app is going to require those management IPs on your devices for it to function. So just keep that in mind as we go through that process there. Now, we're going to take a look at one of the most interesting things I think that we have here in the Nautobot universe. The specific example is finding an IP assigned to an interface, but I believe this is one of the most compelling reasons to use Nautobot, and it is expressed here on this screen. So if you look at this screen is showing us CMDB data, DCIM data, and IPAM data all in one view. And that is a unique Nautobot capability. Most other tools, those different pieces of data are going to be separated from each other. The CMDB data is not connected to the DSIM data, which is not connected to the IPAM data. But when you use Nautobot, it is and can be. We can actually see a holistic view of our environment. How are things, what's our inventory? How are they connected to each other? And how are we using our IP infrastructure in our environment, all in one screen, all in one view, and all of those relationships between those pieces of data are interconnected. This is a really strong, powerful value add to using Nautobot compared to any other tool in your environment. Okay, so the details of what that means, right? As we look at this screen here, we're going to first, to get to this screen, we're going to go into our Devices tab. We're going to go to the device we're interested in. You could potentially use the search to find it more quickly if you have a large number of devices in your environment. And you're going to navigate to the Interfaces tab. When you first log into the device, or sorry, click into the device, you'll go to the Device tab. You're just going to move over to the Interfaces tab. And here we're able to see all the IP addresses assigned out to the interfaces of this device. So a great use of the way that we can use the data we have in Nautobot and understand how our environment actually is modeled. So just something you might practice if you haven't already done this. Take a quick look at that in either your environment or in the public sandbox is a great place to take a look as well. But then perhaps there's an interface, you're like, hey, it's a new interface. I need to now assign the IP to it. You're going to continue from that screen, and we're going to click on the edit button that you see right here, the little pencil, for this interface where we want to assign the particular IP address to. Right? So we'll click there, and we will end up at this screen. So now we're in the detail of that particular interface, and we're able to then go to our IP address field down here below, and we're able to enter or select, the appropriate host level that has already been created in IPAM. Remembering this field already needs to exist over on the IPAM side of Nautobot for us to select it here on the device. So just keep that basic order of operations in mind so you can be efficient as you move through and do things like, say, assigning IPs to interfaces. Second example practice is finding an IP address in a prefix. So we're going to go to the Prefixes page here using the menu on the left-hand side. We will go into the prefix we're interested. And again, you can notice here, we're using a search option to filter down to things that we're interested in. So we don't have to look through thousands of items, depending on the size of your environment. We're going to select the IP address tab, as we would similarly in any other screen. And then we're going to see all of the host IPs now that have been created on this particular network or prefix. So that would be your basic structure of how I might navigate through the UI to locate and maybe I'm looking for what's available or what's in use, what have you. Now, something that's really common in the world, right, is like we like to document our network services. It makes it easier for us to understand. Some of the times, some of the things are relatively easy for us to remember. UDP67, we know that's DHCP, for example, but it's good practice to document it. It also helps us as we have things that maybe are unusual. We can document those here so we don't have to remember and map those in our head. You can do that by going to the services option in the menu. And you're going to drill in and click on the add button. And now we can actually create out the particular service. So here in this case, we're doing DHCP, its protocol is UDP, and of course, its port is 67. So here's just a great way to be able to have that referenced and documented in your environment. Perhaps you have some things that are unusual. Okay, let's move on to now some example use cases. Had overviewed some quick tutorials there, things you might do. Now let's look at some motivating reasons of using Nautobot and how it really starts to become powerful as you use it in your environment. And these are just examples. There are, of course, lots of other reasons and ways in which you might use Nautobot and its IPAM functionality. Here's just a couple examples. We can verify adherence to IP address standards with Nautobot jobs. And now we're starting to take a look at something we referenced earlier at the very beginning of the webinar, which is not only are we getting the IPAM functionality with Nautobot, and that's a compelling enough reason alone sometimes, but we're also getting access to Nautobot's automation capabilities. And this provides us a tremendous amount of power. Just the basic story, right? We want to ensure we have well-defined IP assignment strategy. It's just good practice and make sure we have efficient network management and security. And using this automation can help us achieve that we have what we expect, that we're continuously monitoring our IPAM database against our predefined IP standards. We can schedule a regular Nautobot job, which is a functionality of Nautobot jobs. You can set them to a schedule, and we can automatically verify that every IP within a subnet adheres to its intended purpose. This could potentially prevent us from wasting IPs. That's just basic resource waste, assigning IPs outside of their designated use case. We might potentially have security vulnerabilities. We're deviating from the standard. Maybe that's now going to have implications on our security policy or other security measures we may be taking. And this automation would help us flag those non-compliant IPs for correction, for someone to go out and investigate, why did this happen? Someone made a mistake, and make sure that we maintain good hygiene in our environment. We have a clean, secure network. So here's, just an example. Perhaps we have a standard like this, where we say, hey, IPs 1 through 10 are our network management and interface IPs, 11 through 20 are our HAs, et cetera, et cetera. Like, these are just our standards that we use to assign out. And this then potentially, as we mentioned, right, might have implications to our security policy. So we can use the Nautobot job to confirm that this standard is now what's actually in the IPAM database. So one example of the way that you could leverage the power of a Nautobot job to actually begin enforcing your particular business logic. And I think that's really the key element here. The Nautobot job and Nautobot's automation capabilities allow you to implement your data verification, your data validation, and your business logic onto the data that you have. This is one of the common challenges we have with data models in general when we don't have this functionality, which is we end up with a bunch of data, but it deviates from our standards or it's not accurate because we don't have the capability to make sure it does meet those standards. And here's a way we can do that. Right? Another example, right? Perhaps we want to verify DNS and hostname records. Again, the idea of the data validation, ensuring that we have accurate and consistent DNS records. This automation here is an example of something you might do within Nautobot, which is to retrieve the FQDN from the DNS database, the IPAM database, and then perform a real-time lookup using the Linux dig command. It's just an example of what you might do, right? And then if a discrepancy is found, we could flag that in a report for further review. This would be a way in which we could compare these two sources. And then as network operators or administrators, we can identify and prevent misconfiguration in DNS and IPAM databases, making sure that our DNS servers are always having the correct FQDN information, which could potentially lead to an outage or some security risk, right, if we have that incorrectly mapped. So using, that Nautobot job to go check the DNS, IPAM, do a actual live lookup, and then compare those things and make sure they're as expected. Just some examples of what we might see out there in a report as we think about that. Okay, so I believe that has brought us to the Q&A, and I know there have been a lot of questions being fired into the Q&A session. So we are going to try to get to as many as we can here as we go through. I think some may have already been answered. I will review those as well for the general benefit of the group here. So a couple of questions coming in as well. So let's see here what we have. So does Nautobot, is it capable of handling Q and Q? Yes, short answer. Nautobot can accommodate use cases as such as this in different locations and thus meet this uniqueness requirement. So that would be a way you could do that by using the location capabilities of Nautobot. We have another question here about pool prefixes. Most DHCP are address ranges, not CIDRs. What would be the best way to model an address range in some particular /24 that's going from some unusual, not a CIDR boundary, right? Maybe it's going from .31 to .254 is the example that we were given here in the question. If it doesn't fall cleanly on a boundary. So at the moment, our default model in Nautobot is using the prefix and cider notation. So if you're going to configure a specific range, and such as .31, that would not be exactly possible within Nautobot's infrastructure today. But if this is absolutely a requirement in your environment, it is possible to modify and extend all of Nautobot's data models. That is possible. You can customize those. So that would be something you could look at that you might want to do if you really required that. The other way is to just use a larger cider. You might end up wasting a couple IPs on either end of your range as far as the way you model that within Nautobot. Would be one potential option. If that does not work for you, you absolutely can extend or customize the data model either yourself, or you can reach out to us and we'd be happy to help you with that. That's something you can do through use of the app ecosystem within Nautobot, which allows you to modify the data model. Can Nautobot jobs perform remediation, or is it reporting only? Nautobot jobs are extremely powerful. And in fact, all of the apps, or most of the apps that you see within Nautobot are powered under the hood by Nautobot job. So absolutely, a Nautobot job can perform remediation as desired. And in fact, it is a place where you can create custom code that you can extend the functionality of the Nautobot platform to whatever you require. It is a full Python environment, which is what's under the hood of the Nautobot job ecosystem, and making that possible. So absolutely, you can do that. If another, so another question here, and thanks you all for firing these at me. Love it. If another platform, for example, Infobox, is being used as the IPAM, what is the best practice for keeping Nautobot up to date with those changes? Yeah, great question. So how do I synchronize data between Nautobot and something else? So I'm going to take this question more generally because this concept applies to any tool, not just Infobox. Within the Nautobot app marketplace, you will find an app called the Single Source of Truth. Its purpose in life is to allow you to synchronize data between Nautobot and something else. It does that via that other tool's API. So long as that other tool has a well-documented API, you're able to synchronize data to or from Nautobot using that app. And that is our recommended way. It's the best way to synchronize data between Nautobot and other tools. You can do that on a regular schedule. You can do it ad hoc. You can fire it from a webhook. There are any number of ways in which you can make that synchronization occur. That's entirely up to you and what makes sense for your environment. Also, an interesting little side note on that, and it's something we see clients doing, particularly when it comes to Infobox, which is you may ingest prefixes and hosts from Infobox, but then perhaps you want to enrich that data on the Nautobot side. So maybe you assign roles or you assign other identifiers descriptions within Nautobot, and you want to push those back in Infobox. You can do that. You can actually pull from Infobox certain sets of data and push other sets of data back. So just keeping in mind, you need to be careful how you do that. So you're not pushing and pulling the same data. But so long as they're different, something in that example, like I'm pulling prefixes and I'm pushing enhanced or enriched data back for those prefixes, you absolutely can do that. So you have a lot of power there in using the single source of truth application. Let's see, I think we had a few more questions coming in. Let's see. We have a fairly detailed question here on, so would it make sense instead of to conceptualize individual CIDRs associated with VLAN as a pool and then a host reservation to block the individual range of +32s as hosts, essentially flipping how a traditional IPAM would model IP space? So I think as we get into these more detailed type questions, these are probably best had on a one-on-one conversation so we can actually go back and forth and kind of really understand what you're after and how you might make sense of this in your environment. So please do reach out to us. We're always happy to set up a session with you. We can explain some of these deeper concepts and really dive into those, as well as potentially give you a more detailed demo if desired in your environment. Got another question coming in here. I manage a provider-like network. Okay. Cool. And we have a namespace for each customer, but that absolutely makes sense. And for each customer, we have hundreds of VRFs. And in those VRFs, we have some IPs and prefixes that are reused. Why this constraint that has been created with duplicate IPs, since this is possible to configure in the real world, right? Okay, so I will explain. So in your case, what you're thinking of as namespaces, we're kind of using slightly different terms. So in this case, what you're probably going to want to do is use the concept of tenant within Nautobot. The tenant is what you're calling a namespace, right? So tenant gives you that capability to say, this is customer A, this is customer B, this is customer C. Then within that tenant, you then want to create your namespaces, right? So you may only have a global namespace, or you may have overlapping IPs, in which case you may have duplicate namespaces within that environment, right? So just keeping in mind that structure, right? So use the tenant concept for your clients, and then use the namespaces as you look at IPAM. So hopefully that answers your question there. Let's see. Just a quick reminder, right, that Nautobot and all of the apps, as I mentioned, the app marketplace, are free and open source and readily available for you to go download. You can get them in our GitHub repository, as well as you can, of course, try them out in the public sandbox at demo.nautobot.com. So just don't forget those key things there. Okay, I think that is all the questions that we got in here as well that I was able to review for you. I'll give you one more minute. If you have any other questions, please feel free to fire them into the Q&A as we begin the wrap up here of the video. So as we move in to the end of this webinar here, don't forget, we do have a guided sandbox companion video. This is a diving deeper video. It's going to go further into these topics that we just discussed here today. It's available out on YouTube, and it is going to cover topics like how to get data into Nautobot using the onboarding application, network importer, and doing things like data synchronization and normalization with other systems of record, which we just briefly alluded to here just a minute ago during the Q&A. Those are available for you if you'd like some follow on there. You can watch me as I kind of explain that there. And again, if you run into questions or have things you're curious about, please do reach out. We're always here for you and happy to help. Oops, went the wrong way there on the slides. And just a quick reminder, a little plug here for the really, really great hands-on Nautobot workshop. This is complimentary. It is for y'all only, those of you that are here on this session today. Again, it's super limited availability. So if you want to get in on this, please do it right away. These always book out really fast. We do have a lot of folks here in this particular webinar. It's very well attended, and there are not as many seats as there are of you. So if you're interested, do it now. Strongly recommend it. And then for our regular courses, we do have a 15% off code for you. It's the code you see here on the screen. We will also probably drop it in the link in the chat. The upcoming courses we have currently scheduled right now in our public workshops is Automating Nautobot with Python and Ansible. This is really going to give you deep under the hood of how you use Nautobot, particularly the Nautobot job infrastructure. That's all what's being powered there, and that's what powers the Nautobot jobs. And then finally, creating Nautobot apps. We alluded to it earlier, that idea that you might want to change the Nautobot data model because you need to for your environment, and you can do that through a Nautobot app. This course will teach you all about that, how you can do those sorts of things, and how you can create your own apps to leverage the Nautobot platform to do things that make sense for you. Thanks everyone for attending. Here's some links for you if you're looking for how I get access to Nautobot or the apps and the marketplace there. Documentation, our Nautobot Cloud, the easy button for using Nautobot, one-click deployment by going to Nautobot.cloud, Nautobot Cloud. And of course, as always, reach out for a demo if you're interested. We can give you a deep dive into topics that maybe are more of interest to you, and of course, answer your questions for you one-on-one. Thanks everyone so much for joining us today. Look forward to seeing you on a future webinar.